All right, solve by factoring. The first thing that we need to do is we need to factor these polynomial expressions into their binomials that can multiply together to make them. And then we can set each binomial equal to 0 and solve for the values of, in this case, g, that would make the whole expression turn to 0. Okay, so I know that we've got g and g because we've got a g squared there. So the only way that we get g squared here is with the g and a g. We've got a negative number here, which means we have one of each sign. So we're going to have a plus and a minus. Okay? And what I'm then looking for, and I'm going to write it down below for a minute and then I'll erase it, is the numbers that will multiply to negative 32 that will add together to be the b value of 4. The b value is the value that's in front of the g. Okay? So what can we do for negative 32? We can either do 1 times negative 32 or negative 1 times 32. 2 times negative 16 or negative 2 times positive 16. Can't do 3, it's not a multiple of 32 is not a multiple of it, but you can do 4. 4 times negative 8 or negative 4 times 8. And aha, those two add together to be 4. Right? Super. So the negative 4 obviously goes that there's the negative in the second one, that you put the 4 there with it to be a negative 4, and then the positive 8. Okay? So now that we've factored this into two binomials, we're going to set each of the binomials equal to 0 and find out what values will give 0 for that expression. So first one we'll do, and I'll do these in a couple of different colors, we'll say, do this one in green, we'll do this one in pink, say g plus 8 might have been the thing that was equal to 0. That would turn the whole thing to 0. And what value of g would make g plus 8 equal to 0? Negative 8. Plugged in everywhere for g would turn that expression to 0. Okay? Or it could have been the one that I underlined in pink. Maybe g minus 4 was the thing that was equal to 0 that turned that expression to 0. We solve for the value of g that would make g minus 4 equal to 0. And we find that g equaling 4 would turn the whole thing to 0. And so we know that in our original, and I'm just going to do this once. Actually, I'm going to write it over here on number 17. I'm just going to do this once so you see it in action, and then you can test it out for the rest of them. But I'm going to write over here on the side the original expression, g squared plus 4g minus 32, and it says it's equal to 0. And so what I'm going to do is I'm going to say, all right, let's substitute g everywhere we see it. With one of the values, let's put in negative 8 first. That one that we solved first, that was the green. And see what we get as a result. Well, negative 8 squared is 64. And 4 times negative 8 is negative 32. And then when we simplify it, 64 minus 32 is 32. And 32 minus 32 equals 0. So you can see that negative 8 plugged in everywhere for g did result in 0, like we expected it should. Okay? So now let's do that again, but let's try the other number. We just tried negative 8, and we find two values. Both values should do the same thing. So let's take the pink one we found was 4, and let's put that in, see what we get. So 4 squared is 16. 4 times 4, also 16. And of course, 16 plus 16 is 32. And 32 minus 32 equals 0. So when we're finding these values, when we're solving, and you can see that we solved for g equals -8 and g equals 4, what we're saying is both of those values plugged into the original expression will result in 0. So if we were making a table of values, let me erase this again. Okay, so let's say we were making a table of values where we said, and I'll just keep writing over here for just a second so you get the idea. Okay, if this was a value of g, and then this was the resulting, what you get when you plug it into g squared plus 4g minus 32, right, the output. If we were making a list of numbers, if we had g equaling -8, we'd find that plugging it in, we would get an output of 0. That's an ordered pair, right? That comma that, that we would plot on the graph, and that has a y value of 0. So when we plot that, it's going to land on the x-axis. And if we calculated all of the different numbers going down this list, we would eventually get to 4 for g. And when we plug that in, it would also result in 0. Okay, and that would be another ordered pair that, when we plotted all of these points, would land right on the x-axis. So these 2 points would result in points on the x-axis in our graph. And anything else in between, if we tried -7, -6, -5, -4, all the way up, right? 1, 2, 3, getting to 4, right? What would happen is you would get non-zero numbers for the output, right? Because those aren't landing on the x-axis. Just these 2 points, because the parabola is only going to cross the x-axis a maximum of twice. Could touch it exactly and then turn right there. The vertex is right on the x-axis, in which case you'd only get 1 point where it touches, or it might turn before it ever reaches the x-axis back in the other direction, and you would get no places where it touches. But you're never going to get more than 2 for a parabola. Okay, so that's the big idea with this. So the rest of these problems I'm going to do more quickly. I'm just going to factor them, and then I'm just going to solve for the zeros. But I just wanted to talk about that and show that real quick. Well, real quick is relative, right? Okay, we're going to now multiply the a value by the c value. That makes -72. And we're going to find the 2 values of the 2 numbers that multiply to -72 that add together to be -21. And it's going to be a little bit of a list. So remember what we're trying to do. We're just trying to identify that pair that adds to -21. If we can see it, as soon as we see it, we don't have to continue the list. Our goal is not to write the full list. Our goal is to find the 2 values we're looking for. So it's fine if we do a partial list and we find it and then we stop. So let's do it. 1 times -72, or -1 times 72. Okay. Now, by the way, if you want to speed things up, and of course, always you do, we could just do this and say, oh, these combine to be -71 when you add them. And then you just know that, well, if we switch the sign like this, we'd get a +71. Neither of those are we don't get a number 21, positive or negative, for those. So you could always just do the first set and then say, oh, if it adds together to be the opposite of what I'm looking for, I just switch the sign to the other one. So let's do that. Okay, 2 times -36, and you can see that those add up to -34. That's not the 21 number that we need. So what else can we do? We can do 3 times -24, right? Yeah, -24. And oh my gosh, they add up to -21. So this is the set that we're looking for, and we do not have to go further. Again, if we had been solving this and we were looking for a +21, and these 2 numbers came to -21, we would just say, okay, then make the 3 negative and make the 24 positive. So anyway, 3 and negative 24, that's great. That's what we want. So now, remember what we'll do. I'll erase those in a second. We need them. Just hang on to them for a second. What we need to do is we need to say, I'm going to write 2z squared. And instead of writing negative 21z, I'm going to write this in two parts, positive 3z and negative 24z. Okay? And once we've done that, we're going to group them in pairs. We're going to say, let's group these two together, see what we can factor out. Let's group these together, see what we can factor out. And for this first one, we can factor out simply a z. You get a z, and then we have left over 2z plus 3. And what can we factor out of this one? Well, if the first one is a negative, if the one with the z term has a negative in front of it, we're going to factor out a negative as well. So we're going to factor out a negative. We can get a negative 12 out of there, out of both of them. And then what do we have left over? We divide negative 24z by negative 12, and we get 2z. And if we divide negative 36 by negative 12, we get positive 3. And that's great because we get 2z plus 3 on both of them. So what do? We bring down each piece of this here and here into one of our binomials, z minus 12. And then our other binomial is what we got twice here and here, 2z plus 3. Yep. Okay. And then we're going to set each one equal to 0. So I'm going to erase the work that we did to get there. Hopefully you followed that. If not, rewind it and watch. I'm going to take all this work away that we did to calculate those numbers, and I'm going to move them up. And we've got z minus 12 times 2z plus 3. And we will then take each one individually and set them equal to 0. So let's take z minus 12, set that equal to 0. And that is one of our answers. And then let's take the other expression, 2z plus 3, set that equal to 0. And solve. And there we go. Those are our two solutions. Okay, let's move it along as we go here. Okay. We do have a coefficient of greater than 1 here in the front. So we're going to multiply them together. 4 times negative 40 is negative 160. And we're listing factors of this. Okay, so 1 times negative 160. And that adds up to negative 159. Not helpful to us. Okay. What about 2 times negative 80? That adds up to negative 78. 3 times, nope, not 3 times anything. 4 times, yep, 4 times negative 40. That's what we just multiplied together to get it. Those add up to negative 36. 5 times anything? Yeah, it's a multiple of 5, ends in 0. So times negative 32. And we add those together, we get negative 27. Those are the numbers that we're looking for. Super. 5 and negative 32. So I'm going to write down here below, let's say the original expression that we had, 4m squared minus, so instead of putting negative 27m, we're going to put positive 5m and negative 32m. Those two numbers that we just solved for. And then the minus 40. Okay, let's factor and see what we get. We're going to group them together. And what can we pull out? We can pull out an m from this first one. And that's all we can get. And what are we left with? We're left with 4m plus 5. And what can we pull out of the second one? Well, we have to pull out a negative because the first one, the m term is negative. So we can pull out a negative, and I can divide those both by 8. What are we left with? We're left with, 4m, and negative 40 divided by negative 8 is positive 5. Does that fit with what we know? Yes, we got 4m plus 5 for both of those things left over. So then we have, as a result, m minus 8 times 4m plus 5 equaling 0. So I'm going to erase the work and move this up so that we can solve for these. I know this seems like maybe it's a long video, but and it will be longer because we still got more problems in it. But this is such an essential skill that this might be a really valuable video for you if you still don't know exactly how to factor. I spoke with Mr. Lakai yesterday, and he just confirmed what I've been saying in class, which is this is a really essential skill. In geometry, you won't see it too much, although you'll see it a little bit. But in Algebra 2, and then pre-calculus and in calculus, you will be seeing this all over the place. And in fact, having this as a strong skill really unlocks the math for you because you can simplify a lot of problems by being able to factor it and see what you can cancel out. Anyhow, this factors down into m minus 8 and 4m plus 5, all equaling 0. Okay, so now what we want to do is set each part, as you know, equal to 0 and solve for the variable that will result in a 0 for that expression, and therefore a 0 for the whole thing. So m minus 8 could be equal to 0. And when we solve for that, m equals 8. That's one of the two values that are going to result in 0. Okay, and then we'll take the second one, and that's 4m plus 5. Set that equal to 0. And m equals negative 5/4 is a second value that will result in 0. Okay, we've got another 3 to go, and we're gonna do them right now. But stay with us. See if you can anticipate what's going to happen. Instead of simply just watching, hopefully at this point you can pause it and try it with the other problems, and then see how you did. But I'm going to move straight on. Okay, and with these, the thing that happens with these is that it doesn't say equals 0. What we need to do with this set is we need to move everything to one side so that it equals 0. Watch what I'm doing here. This, on the right-hand side, it says equals 21, and we don't want it to say equals 21, and we want it to say equals 0. So I'm going to say minus 21, minus 21, and then we will get an expression that says p squared minus 4p minus 21 equals 0. And this is now what we want to factor and solve. Because if it doesn't equal to 0, then we can't use the zero product property. We can't say if it equals 0, one of these things equals 0, then we can solve for it. It just won't work. So now we can factor this. Let's see how we get. We got a p here, we got a p here. We see this negative 21 here as a constant. The only way that we can get the constant term is by multiplying this by this. So we must have one of each sign in order to get a negative number there. So we're going to list our factors of negative 21. As you can see, the number in front of p squared is a 1. It's got a coefficient of 1, this right here. And so we're really just doing this 1 times negative 21, getting negative 21, and listing the factors of that. Okay, 1 times negative 21. And again, I'm going to shorten it up here, and I'm going to do my trick, which is to say, if these add to be negative 20, then, and I needed it to be positive, then we could just switch the sign of it. Okay, but we don't want a negative 20 or a positive 20. We want a negative 4, this term, this middle b term. So what about 2 times anything? No, it's not even. 3 times anything? Yeah, 3 times negative 7. And those add to be negative 4. That's what we're looking for. So that's our set. Yeah? Okay, and since we don't have a leading coefficient or a number in front of the p squared term other than 1, this is actually just 1, we can just plop the two numbers that we found, 3 and negative 7, into the binomials. So this can become 3 because it's a positive 1, and this is 7. It's a negative 1, negative 7. And that's really the extra trick with this, is that you need to first move everything to one side so that it equals to 0. Then we can follow the same technique that we did. So now we've got either p plus 3 equaling 0, which means p would have to be negative 3 in order to set that expression equal to 0. Or we could have p minus 7 being the thing that was equal to 0, and then plus 7 plus 7, p equals 7. That is the other value of p that will result in 0 for this expression. Okay? So we're going to keep doing this with these last three. We're going to say it doesn't equal to 0. It says minus 12 on that side, so we have to add plus 12, and we get 2w squared minus 11w plus 12 equals 0. That's what we want to factor. And because this does have a leading coefficient other than 1, there's a 2 here. Multiply the 2 times the 12 to get 24. And then we say, okay, well, we got a positive number at the end. It must have been the same sign twice. And this right here tells us what it's going to be. They're both going to be negative numbers. They have to add together to be a negative, so they must both be negative if they're the same sign. So we either got negative 1 times negative 24, that's equal to 25, or negative 2 times negative 12, that's equal to 14, or negative 3 times negative 8. That's one that people always miss with 24, is the negative 3 times negative 8. And in fact, that adds to the negative 11 that we want. Okay, so that's what we want. So we're going to get rid of all this. And we're going to rewrite this so it says 2w squared minus 3w minus 8w. We used those two numbers as the coefficients. So instead of saying negative 11w, we just split it into 2. Negative 11w is just negative 3w and negative 8w. And then plus 12. Okay? It equals 0, but what we're really trying to do here is then we're trying to say, now we're going to group these. We're going to group these like this and like this and see what we can factor out. Okay? So what do we get? Well, from 2w squared minus 3w, the only thing that we can factor out there is a w. Okay? And what are we left with? We're left with 2w minus 3. From negative 8w plus 12, what can we factor out? Well, we have to factor out a negative because the variable term has a negative in front of it. And we can get a 4 out of both of those. So if we divide negative 8w by negative 4, we get 2w. And if we divide 12 by negative 4, we get negative 3. And they both result in 2w minus 3 left inside, so that's great. So then what this turns into is w minus 4 times 2w minus 3 equals 0. And I'm going to erase our work and move that to the top so that we can then factor all this. Again, you can always go back and watch what I just did, because I'm erasing the work, and so you can't see what it is that I just did if you're looking now, but you can certainly reverse the video, rewind the video. Okay, so that's what we had. That broke down into w minus 4 and 2w minus 3. And when we set those equal to 0, we say maybe it was w minus 4 that equaled 0. Add 4 to both sides to find out. W equals 4. Or it could have been 2w minus 3 that was equal to 0. And we get 2w equals 3. Divide both sides by 2. And we get w is equal to 3 over 2. The second value. That would set the whole thing to 0. Okay? One more, and let's get it done. Okay. We want it to say equals 0, so we do minus 16 from that side and minus 16 from that side, and we get 9b squared minus 16 equals 0. And this is an easy one to factor because I can see that these are two perfect squares. The first one is 3b times 3b. And then you're subtracting from that perfect square another perfect square of 16, which is 4 times 4. So how do we factor this out? We say, we break it down into 2. That will have 3b in the front of each one. Square root of 16 is 4. It'll have a 4 at the end of each one. And we have 1 of each sign. That's what the difference of two squares does. And remember why we don't have that middle term, because this will result in 12b when you're doing FOIL. First we'll get you that first term. Outer will get you negative 12b, and inner will get you positive 12b. Negative 12b and positive 12b cancel out. So that's the first term is there. Outer and inner cancel out, and then last, positive 4 times negative 4 is that right there. So we just got to set these both equal to 0. So maybe it was 3b plus 4 that was equal to 0. And that would be b equals negative 4/3. That's one of the values. And the other value would be, let's see, if it was 3b minus 4. (3b equals 4). And I normally like to rewrite it instead of just dividing, but I'm running out of room. So we can then say b equals 4/3. And you notice that they are exact opposites. Just a second. -4/3 and 4/3. That's what happens when you get the difference of two squares. So yeah, that's it. Watch that video twice if you need to, but hopefully by the end of that, you really know what's going on there.